Can you solve this higher level question above me? It's about the pH of weak acids. It's very tricky. It is very long, but if you want to go the extra mile, get your predicted grades up, stay with me until the end of this video. What is the pH of a 0.1 moles per liter weak and monoprotic? We're going to have to assume that acid with Ka equals to 1 times 10 to the negative 5. Okay, so we have to assume two things from these two assumptions. We have to know three things, and from these three things, we are going to go through 8 situations. Don't lose count. I'll keep track. So we're assuming two things. Thing number one, the acid is weak, and we are going to assume that in addition to being weak, this acid is also monoprotic, which means that there's only one H plus per molecule of acid that dissociates. What do we have to know? Thing number one, weak means that the dissociation is reversible. So the concentration does not correlate straight away to the pH. This dissociation is reversible. Thing number two, if an acid is weak and monoprotic, the concentrations of H plus and A minus are equal. Therefore, when they're multiplying, we're just interested in the concentration of H plus. So H plus times concentration of A minus is equal or the same thing as concentration of H plus squared. This only works on acids that are weak and monoprotic. Again, monoprotic dissolves 1 hydrogen plus per molecule of acid. We can go through our 8 situations. Count with me. Situation number 1. We know that the expression of the Ka is the multiplication of the concentration of the products to the power of their coefficients. All the coefficients are 1, so all the powers are 1, so we're not going to represent any of those powers, divided by the concentration of the reactants. In our case, we just have one reactant, which is the undissociated acid, which the concentration was provided for us. After situation number 1, knowing that for weak and monoprotic acids, you have the same ratio of H plus and A minus, which is the rest of the acid. So this is going to be the same thing as H plus squared. So situation number 2, Ka is now equal to concentration of H plus squared divided by the concentration of our undissociated acid, which again, the concentration was provided for us. So now we are going to plug the numbers. Knowing that the expression is Ka equals concentration of H plus squared divided by the concentration of the undissociated acid, the concentration is 0.1, which is the same as 10 to the power of negative 1. And the Ka is 1 times 10 to the power of negative 5. So the Ka is on the left side of the equation. We're going to plug 10 to the negative 5 on the left side of the equation. And that is situation number 3. Let's continue, shall we? Ka is equal to 10 to the power of negative 5 equals the concentration of H plus squared divided by 0.1 or 10 to the negative 1. Now, in order to get rid of this 10 to the power of negative 1, we have to multiply both sides by 10 to the power of negative 1. So multiplying the right side by 10 to the power of negative 1, 10 to the power of negative 1 cancels out multiplying and dividing. Multiplying by 10 to the negative 1 on the left side, 10 to the negative 5 times 10 to the negative 1. According to the properties of exponents, we have to add the exponents over here. That gives us 10 to the negative 6 is equal to concentration of H plus squared. We got rid of the 10 to the power of negative 1. So that's situation number 4. Situation number 4, we got 10 to the power of negative 6 is equal to the concentration of H plus squared. Situation number 5. Let's get rid of this squared here. So I have to square root both sides. Square rooting the concentration of H plus squared, the squared cancels out with the square root. So in situation number 6, we only have concentration of H plus. Now on the other side, square root of 10 to the negative 6.
How do we do that?
That would be the same thing as powering 10 to the negative 6 by 1/2. And if you remember properties of exponents, 10 to the negative 6 to the power of 1/2, we multiply negative 6 by 1/2. which brings us to situation number 7. In situation number 7, we have that the concentration of H plus is equal to 10 to the power of negative 3. Now that we figured out the concentration of H plus, we just have to plug it on the pH formula. We know that situation number 8, pH is equal to minus log base 10 of the concentration of hydrogen plus. If our concentration of H plus is 10 to the negative 3, we just have to plug it in. Minus log base 10 of 10 to the negative 3. The minus cancels out, the 10 cancels out, and our final answer, the pH is going to be equal to 3. The answer is letter B. Thank you for sticking with me through this very tricky HL question. If you want more questions like this, follow me on Instagram and TikTok at Mr. Diego Tutoring, and please subscribe to my YouTube channel at Crushing Chemistry. And if you want some private tutoring sessions, send me a DM on Instagram. Start your semester right. Let's get those predicted grades up. Have an excellent rest of your day, wherever you are. See ya.